So now here we are on the second step. Actually, in the start, you have observed we have discussed about the four step. One, two. Second step was actually the vector-based analysis, and now we are here on the vector-based analysis. For that purpose, I need to erase all these values. I think this single module will be the longest ever you have studied.
Oh no.
Yeah, okay, okay. But not a difficult. It has a direct connection with your previous study. Something is new is the only thing, the inclusion of the work energy theorem. But that is also
Okay,
not difficult.
good, good.
Okay, let us see the vector analysis. Okay, in the vector analysis, we need to discuss some initial information about the projectile motion. Initially, projectile motion has two component, velocity component. Also, we know initially it has two velocity components. For example, if we are talking about the projectile motion, and it is like some type of this, and as it is two-dimensional motion, it is having two velocity components. For example, we need to resolve a single component into its components, a single velocity part, horizontal component Vx and vertical component Vy as it is moving on the top. And on the top maximum height, its vertical component is 0. It is having only the horizontal component Vx. But as it is moving downward, now it again having the two components. Now vertical component is downward Vy, while the horizontal component is still forward Vx. And here you can see horizontal component Vx is actually not changing its direction. It is properly in the same direction,
Hmm.
while Vy is continuously changing its direction. Initially, it was upward, and at the mid or the highest point, it is actually 0. And as it is coming downward, then it is downward directed. So its direction is continuously changing. And here, in case of the projectile motion, we does not consider the air influence, for example, air friction. So in this way, we can consider the horizontal velocity is constant. The only velocity that is getting changed is actually the vertical velocity, and that is actually due to the gravitational pull of the weight downward.
Mhm.
Okay, so one vertically and other horizontally that we have discussed okay, to jump along way, you must run as fast as possible the runway. Okay, that is actually the initial requirement to have a long jump. First of all, on the runway, when you need to move fast as much you can, and then give yourself a large upward kick to take off. Okay, fine. For a projectile, the maximum range for a given horizontal velocity is achieved for launch angle 45. Okay, from the formula of the range, we have observed that is, I need to write the range formula. R is equal to V naught square divided by G sine 2 theta. That is actually the range formula. And from this formula that till now we have understood that range is maximum for the angle that is actually the 45, because at 45 that will become in case of sine to theta 90, and 90 sine give maximum value, that is 1. But that is about the projectile, some type of the bullet that is fired from some way that is having the higher initial push as compared to our motion or the movement on the runway. There is no comparison between our movement and the movement of that bullet. So, as you can say, in we have low energy as compared to the bullet kinetic energy. So, what we need to do, if we will choose some higher angle to have a jump, then we can gain the height, but we can't gain the range, horizontal distance. To gain maximum horizontal distance, you need to reduce the angle. That should not be 45. It should be some smaller angle to gain that. So here they are saying this is why usually the projection angle is most long jump range 15 to 25. And also in the diagram you can consider this is not the angle 45. It is 45 angle can exist some here. Just let me raise it. Okay. it can exist like here. That is a 45. But here, angle of these boys, the boy that is running can be here, like some type of the 25, or as he is saying that the mostly jumper choose the angle 15 to 25 ranges to get the maximum horizontal distance or the range. It is now time to fully characterized motion. Okay, fine. Okay, so let us resume.
Perfect.
Okay, in the first part, what we have to do, we need to find the horizontal and vertical component of the acceleration. As the motion is two-dimensional, then it is necessary that acceleration components should be of two type. And keep in your mind, there is no interference of air friction, then we can consider the horizontal velocity is the constant, then horizontal acceleration ax can be written here. Ax is equal to rate of change of horizontal velocity Vx over dt. As we know here the horizontal velocity is constant, then its horizontal acceleration is equal to 0 because there is no rate of change of horizontal velocity. And as it is moving downward under the action of gravity, for example, if it is lying at this position, it is moving downward due to gravity and due to its own weight, mg downward, then we can write it here. F is equal to m into minus g, because initial push was against the direction of gravity. Gravity is acting downward. We know gravity is acting downward, but as the initial push was not in the direction of gravity, it was against the direction of gravity. So here we are introducing the negative sign with the gravity. And also according to the Newton law, initial push that was provided to the projectile to move can be written here. Ma is equal to m into minus g. You can cancel the mass with the mass, then acceleration will become A is equal to minus g. As g is vertically downward, then you need to introduce here the unit vector that will show the vertical acceleration ay. Ay is equal to minus gj. So that was our first part answer. We have calculated the value of the ax and ay. And but that is not enough. What we need to do next? Such motion is said to be integrable. Integrable. Here we can integrate. That is to say that use the integration rule. One can express the Cartesian coordinate x of t and y of t representing the position of the projectile as a function of time. So we need to determine the equation that will represent x of t and y of t, and for that purpose we need to integrate our this equation. For that purpose we need to write our this equation as it is acceleration along the vertical. We can write ay is equal to d v y by dt is equal to minus g j. And also we can write it dv is equal to minus g j dt. Now what we need to do, we need to integrate it. As g is a constant, g is its unit vector, so we can write it. Then after integration, our equation will become v is equal to minus g t j plus some integration constant that can be considered as a. And to calculate the value of this integration constant, we need to apply some initial condition. Initially, when time was equal to 0, then initial velocity was v is equal to v naught. And when we will replace this condition in our this equation 1, then our equation, final equation will become v naught is equal to minus g j into 0 plus a, and that will results a is equal to V naught. Now what you need to do, you need to put this value of the V naught in our equation 1. Then our final equation will become here, after putting the value of A, V is equal to, just rearranging, putting the value of V naught initially, minus G J T. So that is our final equation in case of the velocity. But also we need to write this equation into the component form. But to write it into the component form, we need to discuss the diagram of projectile motion. For example, if the diagram of the projectile motion is like this and its initial velocity is directed like upward, for example, in the two-dimensional, it is more upward. That is actually my mistake. But you need to understand, I am now resolving it into its components, horizontal and components. Its velocity name is V naught. Its vertical components is V naught y, and its horizontal component is V naught x. So you can consider it is actually a right triangle. From right triangle, you need to calculate the value of the cos theta. Cos theta is equal to V naught base over hypotenuse, V naught x over V naught. Then after rearranging, value of the V naught cos x is equal to V naught cos of theta. That is the value of horizontal component of the velocity. And similarly, we can calculate the sine theta from this equation. Sine theta is equal to perpendicular over hypotenuse. Perpendicular is V naught y divided by V naught. Then after rearranging, V naught y will become is equal to V naught sine of theta. That is the vertical component of initial velocity. Now what we need to do, we need to break or resolve this equation into its components. Then our horizontal and vertical components will become Vxi plus Vyj is equal to V naught xi plus V naught yj minus gt j. Drawing a line between them to show that these are actually different. Okay, fine. So now what next I can do here, I need to put their components in this equation that we have made here in the rectangles here and here. Okay, let me change the color so that results seems to you different. Vxi plus Vyj is equal to, value of the V naught x is equal to V naught cos of theta. So putting here V naught cos of theta I plus value of the Vy here V naught sine of theta j minus gtj as it is given here, minus gtj. Now what you need to do, you need to write separately the horizontal and vertical components. So Vx is equal to V naught cos of theta. That is the only term here for the horizontal component. And for the vertical component, Vy is equal to V naught sine of theta minus gt. So you can consider these are two equations. One of them is representing the horizontal velocity, and second one is representing the vertical velocity terms, and we will later utilize these equations. The most good thing in this module is that I have enough space to solve the questions in this module.
That's good.
Okay. Okay, but keep in your mind our purpose where we have to reach is to calculate the positions horizontal and vertical x of t and y of t. That is our goal in this question. Okay, to reach that point, what we need to do? We need to we need to integrate this equation of the velocity again. For before integrating that equation, I want to rewrite that equation. V is equal to V naught minus GT J. Now is the final step to reach towards the position. I need to write as the velocity is the rate of change of the position. So I can write it dr over dt is equal to V naught minus gt j. Then dr is equal to V naught minus gt j into dt. So it is a time I can integrate it, integration on the both side. Then our relation will become R is equal to, writing it directly, V naught T minus half GT square J plus some integration constant, that is B here. And again, we need to find the value of the integration constant. For that purpose, we need to introduce the initial condition. When time was 0, then its initial velocity v was equal to v naught. Then its initial distance r was equal to r naught. Actually, these are equal to 0. R naught is 0 and time was 0 because projectile was still in our hand. It was not in motion. Then it was not covering any distance. Just we are introducing here, and at the end we will put it equal to 0. So here just we are fulfilling the requirement of an equation. So when I will replace this condition here in this equation, the time term will be vanished. The only term that will remain is r. So our b will become equal to r naught for the initial case. Then our final equation, after putting the value of this constant b, will become v naught t minus half gt square j plus r naught, which is the replacement of this integration constant b. And what we need to do now, we need to write it into its components form. Then when we write it into its component form, then as the motion is two-dimensional, then component will be 2 xi yj is equal to v naught. Component will be v naught x plus v naught y into t minus half gt square j plus r naught will have two components, x naught I plus y naught j. Now what I need to do, I want to separate the component horizontal and vertical component. So the horizontal terms are for the x are here and only these three terms. Then I can write x is equal to v naught x t plus yes, x naught, and I need to put the value of the v naught x component, that is v naught cos of theta into t plus x naught is equal to x. Okay, same thing I need to do for the vertical distance, that is having the terms for the y, first term, second term, and third term. Then our equation will become, for that case, y is equal to v naught y t minus half gt square plus y naught initial vertical distance. And I need to introduce the component v naught y of the velocity. Then our equation will become v naught sine of theta into t minus half gt square plus y naught. Now I can say initially when the projectile was in our hand like the ball and we have not thrown that, then at that time initial distance was also equal to 0. So I want to remove this x naught and y naught. Then my final equation will become for the x is equal to v naught cos of theta into t, and y is equal to v naught sine of theta into t minus half gt square. So these are final equation for the as he was saying, we need to introduce as a function of time, and you can see here time is introduced because it was a requirement. We need to introduce the horizontal and vertical position as a function of time, and you can see in these equation the presence of time. So these are equation that we need to use in our upcoming problems. Okay, what is the next part of this question? You need not to worry. At the end, we will have a revision on the notes. Okay. Uh, representing the okay. We are now on the part 5 from the vector-based analysis. Uh, the exact formulas of range and time of light. In this case, from this analysis, we need to find the exact formulas of time of light and range. Now I need to remove this initial data from this because we don't need it now. Okay, fine. So first of all, we are actually working on the time of flight because in case of the range, we need the factor of the time of flight. So first of all, we need to calculate the time of flight. Again, I am drawing the diagram of the projectile. If the projectile is moving and gaining some height and returning to the ground, then the time taken by the projectile from the point of projection to the point of landing is called actually the time of flight. I can just represent it by different color. Through this motion, the time that is taken is actually called time of flight. Okay. At the top position, in this whole movement from the point of projection to the point of landing, we are observing initially it is covering maximum vertical height as a ym in the first half, and in the second half it is moving down the same height as a ym, as these two vertical distances are opposite to each other. So I am writing it as a second time distance is minus ym. First time is ym during the projection, and during the landing it is a distance minus ym. So if the some projectile is moving from the point of projection, gaining some height, coming downward, then what is its net displacement vertical? Vertical net displacement will be equal to 0. You can write ym, initial distance, final distance minus ym is equal to 0. So there is no vertical distance covered in this case. And the equation for the vertical motion that we have made for the displacement is here, and we need to use this equation for the time of flight. Y of t is equal to v naught sine of t minus half gt square, and here I am using this equation to calculate time of flight. So I can write y is equal to v naught sine of theta into t minus half. Okay, don't worry. I have enough space in this case. Here you can see free empty pages.
That's good.
Okay. So instead of disturbing our lecture in the printed writing, we need to use it.
Yes.
Okay. Y is equal to V naught sine of theta into t minus half gt square. Okay, we have discussed that its net vertical distance distance is equal to 0. How is it 0? Also we have discussed. So we need to put it equal to 0. And remaining equation can be written like V naught sine of theta minus half gt into t. Just I'm taking the common t. So t cannot be equal to 0. It is a time of flight, because if the body is moving, you can say initially time can be 0, but during flight it cannot be 0, because during its motion it is taking the time. It will have some value. So if t is not equal to 0, then this term can be equal to 0. So we are putting it equal to 0. We not sine theta. Because if you will think mathematically, then only two possibilities are here. If t is equal to 0, if t is not equal to 0, then second term should be equal to 0. So instead of putting the first term equal to 0, we are putting the second term equal to 0. Okay, fine. Now rearranging half gt is equal to v naught sine of theta. And just rearranging, as I need the time t of flight, then our equation will become 2v naught sine of theta over g. That is a relation for the time of flight. But as he has not told to us to calculate the time to reach the maximum height, so we will not calculate that. Next part is to calculate the range. Now, in the next case, we are calculating the range. What is the range? The maximum vertical horizontal distance covered from the point of projection to the point of landing is called range. So we can consider this horizontal distance is actually range of projectile. So the equation in the physics for the horizontal distance we know is equal to Vt. We already know about it. But as we are talking for the range, and range is horizontal distance, then for the horizontal distance, only the horizontal velocity will be the use. Oh, so we can write this equation as a product of horizontal velocity and time of flight. So this horizontal velocity will have the component v naught of cos of theta. Vx is equal to v naught cos of theta. And also we have calculated the time of flight, this relation t is equal to 2 v naught sine of theta by g. So you need to introduce or the put these two values in this equation. Then our equation will become is equal to value of the Vx is v naught cos of theta multiplied value of the t is 2v naught sine of theta by g. Here you need to multiply. As a result, product will become v naught square divided by g, and trigonometric value can be written combined 2 sine of theta cos of theta. And also from the trigonometry we know about this formula. How can we can close it? Sine 2 theta is equal to 2 sine theta cos of theta. And also I need to replace this value by this sine 2 theta. Then our relation of the range will become r is equal to v naught square divided by g sine 2 theta. That is our final relation for the range. So let us check the question now. Instead of this, there is any other demand of that question. Let us check. Okay, we have here the part 6, and the sixth part eventually proved that motion of center of mass of projectile characterized by the parabola. So here we need to prove that this motion is actually the parabolic motion. For that purpose, again we need to use the last two equation that was for the position. Which two equation? I need to rewrite those two equation to clear the scenario. First equation was for the horizontal distance x is equal to v naught cos of theta into t. And second equation is y is equal to v naught sine of theta into t minus half gt square. So we are here to prove it as a projectile equation. From the equation we need to prove. You can say it is equation 1 and it is equation 2. Okay, from equation 1 we need to isolate the time. Then our equation will become t is equal to x over v naught cos of theta. Now what we need to do? We need to replace that value of the t in equation 2. Then our equation 2 will become y is equal to v naught cos of theta value of t, that is x over v naught. Ah, it is actually the sine theta. You are not having a proper concentration here.
I was just about to say that is it sine, but then I was thinking if you're gonna write.
It is sine theta. Sine theta over v naught cos of theta minus 1 by 2 j x over v naught, just replacing the value of t, v naught cos of theta square of this value. Okay, now you can cancel this v naught by this v naught. Then our equation will become is equal to uh, x tan theta minus, also we can write this equation gx square divided by 2 v naught square cos square theta. Okay, just I want to rearrange this equation to make it the parabolic equation. For that purpose, later I will introduce some constant, but before that, uh, x into tan of theta minus g over 2 v naught square cos square theta. I need to close it into the bracket into x square. So I want to introduce some constant that is equal to tan of theta and b is equal to g over 2 v naught square cos square theta. Yes. Then my this equation will become this equation. After introducing these values in that equation, y is equal to a x minus b x square. So here what I am doing, I'm just replacing this value by b as I have already told to you, and this value by a as I have already mentioned. So now it has become the proper parabola from this equation. Hence, it is proved that our motion of this is actually following the parabolic path because it is resembling with the parabolic equation. Is it clear?
Yes, it's clear.
Okay, now you need to have a revision so that everything should be clear so that you will be successful in your exam. Okay,
This is a
fine.
bit difficult. Like I don't know if how good I'll be at doing this by myself.
It is actually a technical. It is not very difficult. So, why I'm repeating again, because I want if something is skipped in your mind during concentration, so here you need to recheck that. Okay.
Yes.
So we are talking about the projectile motion, and first part was to represent its horizontal and vertical component of the acceleration. So as we have observed that its horizontal component is not changing its direction and there is no interference of the friction of the air. So there is no force along the horizontal axis. As a result, its horizontal velocity is zero. And for the acceleration, we know the rate of change of velocity is called acceleration as there is no rate of change of velocity, horizontal velocity. So its horizontal horizontal acceleration is equal to 0. And he was also demanding to calculate the vertical acceleration, but vertically velocity changes due to the attraction of the earth, attraction of the gravity, and why is it is attracted due to its weight. So we can write it F is equal to m minus g. Already I have told minus g because its initial motion is against the direction of gravity. Gravity is directed downward while its initial motion is against the direction of velocity, initial velocity. So introducing as a minus g. So, as the initial push, according to the Newton's second law, if you have a mass, you need to give it initial push, then it will gain some acceleration. So, for that purpose, we have the relation F is equal to MAY, simplifying, and its vertical acceleration is this one. That was actually its second part. First part, question second. Here, here, where? Yes. Here you can see horizontal and vertical acceleration that we have calculated. And also in the same part, he is demanding to calculate the positions x of t and y of t. In case of the exam paper, the most important first thing is just to read almost 2 to 3 times carefully and understand the question before solving it. It
Yeah.
may be possible they just give some questions to make your you change in your mind, just deceive your mind. So it is necessary to read it 2 to 3 times to understand accurately and give the answer to the point as that is demanded in the question paper. Okay, so now we are calculating that is demanded in this question, the horizontal and vertical distance. So we are taking the vertical acceleration because it is here, and the horizontal acceleration is equal to 0. So integrating it on the both side, because in the question you can see he is saying that these are actually integrable. So we are using that integration rule to calculate it is equal to this, integrating both sides, having some integration constant, applying the initial condition when t was equal to 0, v was v naught, then value of a is equal to v naught, putting that in equation 1, then we have an equation second. And also we are writing it in its component form, vxi plus vyj is equal to v naught xi plus v naught yj minus gjt. Okay, from the diagram we have calculated right triangle already. I have told to you value of the v naught x, v naught y, and putting that value in our this equation C. After putting these values in equation C, then my relation has become like this. Now I am isolating the value of the horizontal component velocity and vertical component velocity, that has become like this. And now rewriting and integrating equation, because our goal is to reach on the position, not on the velocity. So vertical and horizontal position. So rewriting and integrating. Integrating it, finally I have the relation for the position R is equal to V naught T minus half GT square plus B, and at T is equal to 0, V is equal to V naught, and R is equal to R naught. So I am putting these values in this equation. The T terms will be equal to 0. So B will have the relation B is equal to R naught, and putting back. Now, again, I am resolving the values in this equation of the position into their components, x and y components here for the velocity 2, and putting their velocities components in this equation. Then our equation has become like this. Now I am isolating the horizontal components. So my horizontal component of the position has become like this, and vertical component of the position has become like this. But initially we know at time t is equal to 0 and projectile was still in our hand, it was not moving, then this distance was equal to 0. Then our final equation are here 4 and 5, and we need to use these equations. So in the first case we are calculating the range is actually horizontal distance, r is equal to v naught x multiplied by t, and t is the time of flight, that is having the value, and horizontal component of the velocity is v naught cos of theta. And putting these values, simplifying and trigonometric rules, then range is equal to this. And next is time of flight. from equation 4, we know from equation 4 which is equation 4, but you need to skip this step that is actually not needed here. From equation 5, y is equal to v naught sine of theta into t minus half gt square. And already I have told to you this projectile move and gain maximum height and return back to its ground. So its net vertical distance is equal to 0, y minus y. During gaining height, it is y, and during losing height it is minus y, same distance but opposite direction. So vectorally when you will add, then its sum will be equal to 0, so net distance is equal to 0. Then our above equation will become like this. So taking the t common, here you can say t is not equal to 0, but if this t can be equal to 0 or this can be equal to 0, so we are considering this is equal to 0. So our final time of flight is equal to 2 v naught sine of theta over g. But if you need to calculate the time to reach maximum height, then you need to use the equation of the vertical velocity, that is v naught sine of theta minus gt is equal to 0. At the maximum height, it is having its vertical velocity, as you know, equal to 0 at this point. So at this point vy is equal to 0. Simplifying, it is a time to reach the maximum height. And next was the question to prove it that this motion is parabolic motion, here projectile characterized by parabola. So we are here proving. So we know time from equation 4 and 5 that we have lastly checked t is equal to x over v naught cos theta. From equation 5, y of t is equal to v naught sine of theta into t minus half gt square. Now putting the value of the g here from this equation, then our equation will become x, you can cancel v naught by v naught, x tan of theta minus gx square to v naught square cos square theta. Okay, isolating these values and considering these are the constant a and b and replacing values a and b, then our final equation will become the equation of the parabola. Hence, we have proved that our equation is actually the equation of parabola. Trajectory is parabolic. Is it clear?
Yes, it's clear.
Okay, okay. Still, we are on the question number 1.
Oh no.
But I think it is the last part that is about the energy analysis.
Good.
Okay, congratulations for choosing such a long journey.
Yeah.
Okay, I need to make some space to solve the last part. Okay, energy analysis. We are on the energy analysis. Okay, when the projectile is still in my hand, for example, this is a projectile, it is my in my hand, it is not, it does not having any type of the motion. So its horizontal kinetic and potential energy both are equal to 0 because it is just at the point of projection. When we will move it, then initially it will have some kinetic energy initially because of its motion, while its height will be equal to 0 initially, then its potential energy will be equal to 0. When it will gain some height, then it will have some energy. For example, let me make the diagram. Okay, if I am dealing a projectile that is in this projectile motion, then initially at this point origin, its both kinetic energy and potential energy are equal to 0. But when just you push it, just you throw the ball, during that time, potential energy is still equal to 0 because initially it is not attaining some height, but its kinetic energy will have some value. For example, if that ball is having the mass m and velocity v, then its kinetic energy will become half mv square. And at this top position, it is having the height and its kinetic energy both. For example, at this top position, we have only the horizontal component of the velocity, that is Vx, and it is having some height Ym. Then at this position, it will have both type of the energy, potential energy plus kinetic energy. And at the ground position, it will have again both potential and kinetic energy equal to zero because law of conservation should be satisfied here. Finally, after hitting the ground, it will have both the type of the energy is equal to zero. Okay, fine. So let us check the statement of this part. And let us consider the object of the mass m has no potential energy in the beginning of its motion t is equal to zero. Doing so, we arbitrarily determine potential energy reference. Consider this initial point as a zero energy point. As a consequence, initially the total energy of the particle is only kinetic energy. As we have already discussed, what does it mean initially? When it was just